All right, lesson 7.2, looking at task 4. So we're still converting between forms of arrhythmic sequences. Given a recursive rule for an arrhythmic sequence, you can write an explicit rule. Similarly, given an explicit rule, you can write a recursive rule. Consider the sequence defined by the recursive rule shown. G of 1 equals 120. So that means my first term is 120. So it's going to give us the recursive rule, which means you take the previous term, and you add 18 to get the next term for all n greater than or equal to 2. Suppose you want to write an explicit rule for the sequence. What information do you need to write the explicit rule? Select all that apply. All right, we do need the first term because we have to find the previous term. So we have to take the common difference and subtract it from that. So we do need the first term. And we also need to know what the common difference is. So the last term we don't need. The difference between the first and second term. These are consecutive terms, so that's what we need. The difference between the first and the last term, so we don't need that. We need the common difference between consecutive terms. Alright, so use the recursive rule to find the value that you need to write the explicit rule. Then complete the statement. The first term of the sequence is, the first term is 120, and the common difference is 18. Alright, so it says, what is the explicit rule? So to get the explicit rule, we have to think about the previous term. So if I take 18 away from 120, that gives me 102. And then I just do 102 times 18 times n, whatever the term is. All right. Check your explicit rule to verify that it gives the same value for the recursive rule for G of 3 and G of 5. Alright, so if we go back up here and we look, okay, so this rule tells us to take 120, that's the previous term, add 18 to get the next term. So G of 1 equals 120. G of 2, I'm going to add 18, so I'm going to get 138. G of 3, I'm going to add 18 to the previous term, so add 18 to this and I get 156. Add 18 again. Oh, sorry, I wrote 3 again. That should be G of 4, that's my fourth term. So I add 18 to this and I get 174. And let's add 18 one more time to get my fifth term. So 174 plus 18, 192. All right. So that's using the recursive rule. And it says write an explicit rule. So here's my explicit rule given here. So we've got G of n equals 102 plus 18n. So we want to know G of 3 and G of 5. So we can plug in 3. So 102 plus 18 times 3. So G of 3 is going to be 156. And then we want to find G of 5. So we're going to have 102 plus 18 times 5. And I'm using my calculator here, so you can check me if you want to. Alright, so G of 3, I got 156 here and 156 here. G of 5, 192 and 192. So it says check your explicit rule by verifying that it gives the same value for the recursive rule for G of 3 and G of 5. Fill in the values. So 156 and 192 And yes, we can see that those are going to produce the same results. Two equations very similar will give us the same results. All right. Katie says that an explicit rule for the sequence is g of n equals 120 plus 18n minus 1. Which statement is true? Katie's rule is correct. Well, this is not the same as this because she has the minus 1 here. Katie's rule has the incorrect common difference. 18 is the common difference, so that part's correct. Katie's rule has the incorrect first term. 120 plus the negative 1 gives you 119. So that would not be the first term. So that would not be correct. All right, if you have any questions about task 4, let me know. All right, lesson 7.2, task 5. Graph arrhythmic sequences. The table shows the term of an arrhythmic sequence and the position of each term in the sequence. Graph the sequence and then write an explicit rule for the sequence. All right, so the graph has n is 1, 2, 3, 4, and 5, and then f of n is 35, 53, 71, 89, and 107. So to get from 35 to 53, we add 18. And then to get from 53 to 71, we add 18. And then we add 18 and we add 18. So this is an arrhythmic sequence with a common difference of 18. All right, so they've just graphed these as ordered pairs. You can see this is 1 and 35, 2 and 53. So we got 1 and 35, 2 and 53, 3 and 71, and so on. Remember, this is discrete, meaning only the points are showing. It's not a line connecting them. A discrete graph has just the points, not a line connecting them. All right, so fill in the blanks to show the sequence represented by the graph. All right, so the sequence is 35, 53, 71, 89, and 107. Remember, the n is just what term we're looking at. The sequence actually is the f of n. All right, fill in the blank to describe how the fifth term in the sequence is represented in the graph. So the fifth term is 5 and 107. It's represented as an ordered pair. All right, write an explicit rule. So you've got the first term is 35. You've got a common difference of 18. So we're going to have the first term plus the previous term times 18. So the previous term, what comes before 35, so we'd have to take 35 minus 18 to get this previous term. So 17 plus 18n. So that would be an explicit rule. Okay? And that's limited for all n between 1 and 5. So they've limited the domain. They only have numbers 1 through 5. So that means that's all that has been graphed as well. Could you continue it? Yes, since you know the pattern and you know the equation, you could continue it, but right now that's all we're going to look at is n between 1 and 5. All right, choose the words or phrase to complete the explanation of why 35 is substituted for f of 1 and 18 is substituted for d. Well, 35 is your first term. So 35 is substituted for f of 1 because it is the first term, and 18 is substituted for d because it's the common difference. All right, D part. Explain why the domain values are limited to n between 1 and 5. It's just limited because that's all that's in the table. That's all we're looking at. So because it's I don't think it really says why. The table shows the terms of an arrhythmic sequence. Graph the sequence and write an explicit rule. So that's all we're given. So we're not going to worry about we're not going to worry about anything beyond 1 and 5. So this is the domain given. That's the numbers that we work with. All right, if you have any questions, let me know. All right, lesson 7.2, task 6. The graph shows an arrhythmic sequence. Write an explicit rule for the sequence. Then use the rule to find f of 8. All right, so you can see that there are 8 dots on the graph, and the first 3 have ordered pairs. So 160, 290, 3, 120. So the first number in the sequence would be 60. And 90 minus 60 is 30. 120 minus 90 is 30. So you can see the common difference here is 30. And you can see that from the information given. So the first term is 60. So f of 1 is 60. The common difference is 30. So then we're just going to plug that in and find the explicit rule. So we're going to take the first term and subtract to get to the previous term. So that would be 60 minus 30, or 30. And then we can do 30 plus our common difference of 30n. And that's going to be for all n between 1 and 8. Why between 1 and 8? Because that's how far our dots go on the graph. So that's what's graphed. So that's what our domain would be. Explain why the domain values are 1 to 8. Again, because that's what's on the graph. Use the rule to find f of 8. All right, so all we have to do is take 8 and plug it in. So 30 plus 30 times 8 equals 270. So you can check that. Complete the blanks to show the point that represents f of 8. Well, 8 would be your n, or your x value, and 270 would be your f of n, or your y value. So this would be your ordered pair, 8 and 270. All right, if you have any questions, please let me know.